Hey, how's it going? Hi, did you know that, Sea of Thieves, the video game, it's not a realistic video game? If you didn't, or you don't care, I cared enough to figure it out for you. It's not realistic. I'll just let you know if you don't want to watch this. But if you'd like to watch it, then here we go. So the very first thing we need to do to figure out why it's unrealistic is, we need to take a look at our ship. That's our ship. It's a sloop. A real-life sloop, luckily, because, you know, pirates used real ships. They used real ships to model said ships. The real-life version of a sloop in-game is 60 feet, and the in-game is 989 pixels. So we divide our 60 feet by our 989 pixels, getting a single pixel equivalent to 0.018491405445536 meters. So we know how long our sloop is. That's not what's important, because what we're trying to figure out what's unrealistic about this video game is our ability to swim down. We swim to the bottom of an ocean monument, no gear, no submarine, no nothing, and we just freehand it. It's very impressive, I would say. Just right now, we're gonna find it. How fast I swim per second. I measured it out for 9 seconds, being 842 pixels, divided that by 9 to get the 1 second, being 94 pixels per second. We can multiply our 94 pixels by how long 1 pixel is to find our distance. So we travel 5.7027 feet per second. Hey, really quickly, when I said feet for 5.7027 feet, that wasn't wrong. That is the actual measurement. I just misspoke and said feet first and didn't say meters. So, yeah, sorry. Back with the video. Now, we're going to use that later. So, just keep that in mind. We're going to use that later, though. But we have to find gravity. Gravity is an issue, because if we're swimming down and gravity is like 1 meter per second squared of gravity, it's not gonna hurt. It's water, like we're floating. So we need to find gravity. To find gravity, I had to use one of the only objects in game that actually has any form of gravity, like follows any laws of it, because most games are just a frame-to-frame drop for some reason, rather than actually just falling to the ground. They just frame drop. So cannonballs, because I don't want to measure the distance, the mass and acceleration of a real person. I use a cannonball shot out of a cannon. So this is how we're going to find gravity. Our force of gravity is mass times acceleration, and we'll start with mass. Our mass is equal to volume times rho, rho being density of what the object's made of. Cannonballs are made of pure iron, so we can use that to move on. Our volume, the equation is 4/3 pi r cubed. Measuring out what the cannonball's diameter is, just from point A to point B, we get a diameter of 5.01117087569 meters. And then dividing that by 2 to find our radius, or our r, we get a radius of 2.505585438 meters. And then plugging that r into the r within volume, we get a volume of 65.88950704 meters cubed. So we have the first half of the puzzle for one of the mini puzzle pieces. The other puzzle piece is rho. Rho is really easy. Just quite literally do a Google search to find what the density of iron is. The density of iron is 78,000 kilograms per cubic meter. So plugging that number into our volume equation for mass, we multiply those two, and we get a mass of 51,393.8154912 kilograms. So, they can take a hit. The Sea of Thieves pirates are very strong. Like, they've hit the gym more than any bodybuilder ever. Like, you can get hit by a cannonball in this game. Those cannonballs are traveling fast, and they weigh that much, so that's gonna hurt. So yeah, avoid these cannonballs and the punches from these dudes. Jeez Louise, I don't want to get punched by these guys if they can lift that with ease. Now, The other piece of the puzzle for force of gravity is our acceleration. Our acceleration is velocity divided by time. Velocity is delta d divided by delta t. It's really just our distance divided by our time. So finding our distance traveled by measuring from the little red line on the top up here and the little red line on the bottom, we get a distance of 13.427603533333136 meters in the span of 3 seconds. So we divide that by our 3 seconds, and we get we get a velocity of 4.474920118 meters per second squared, which is, I don't know if that's actually fast. I don't have a semblance of that. It doesn't really matter. Because we're not even going to use that number. We're plugging it in to find our real acceleration, which our real acceleration is just dividing that number by 3 again. We get 1.491640039 meters per second squared. So we have force of gravity, or at least the puzzle pieces to solve force of gravity. So we're going to plug in our mass. We're going to plug in our acceleration. We know these numbers already. Multiplying them together, we get a force of gravity of 76,661.07294 meters per second squared. Just so you know, that gravity is 8,000 times stronger than the gravity of Earth. So, don't have hope for these guys. These guys should not be alive if they are human beings, which they are not. I don't believe them to be human anymore. The reason the force of gravity is really important is because of water pressure, because we're swimming down. And swimming down means the water's going to get heavier and heavier as we go, because the force of gravity is pulling it tighter as we go, making it heavier and the pressure of it heavier. So force of gravity has a lot to do with it, and I figured that out. Our water pressure is rho times force of gravity times height, being depth in this situation. And to find our depth, I measured how far we swim from up here, the surface of water, all the way down. And that distance being 79.35 seconds, we can multiply our 5.7027 feet per second times that. That's why we had to find how fast we swim a second. Multiply that by our seconds to swim, getting a total depth of 137.9238176 meters. So we have I think we have every single piece that we need to actually solve this. Now we just plug in. Oh, okay, so by the way, I did use the wrong row for water pressure. I used the row of fresh water rather than salt water by mistake. It doesn't really matter because fresh water is 998 kilograms per cubic meter, while salt water is 1,026 kilograms per cubic meter. So really, my mistake is giving them the best chance of survival. Either way, they're not surviving. So we plug in our row for fresh water. Sorry, don't really mind it. It's not super important. Plug in our force of gravity being 8,000 times stronger than Earth, and our depth of 137-ish meters. Plugging that all in and multiplying it out, we get a lot of different numbers. We get roughly 10 billion kilopascals, which kilopascals really don't mean a lot. And so we'll take the actual number, not the rough estimate that I just gave you guys, and we'll turn that into newtons, giving us 10 trillion newtons. And newtons are helpful because it can be measured in newtons are force, and so we can transfer that into pounds or kilograms, and I did both. So in kilograms, it is 1,074,958,740,416 kilograms, while in pounds, it is 878,356,676 pounds of force. So at the depths that you swim, that is how much you would be feeling. So it gets greater and greater as you go. It would not be fun. Now, for comparison, The deepest dive on Earth of a submarine was 35,791 meters down, and that sub only experienced a kilopascal of 359,273.17 kilopascals of pressure. So our water pressure is 10 billion and a half, really. Comparably to a measly 359,000, really. So this is an insane amount of pressure we are feeling. We have never gone this deep. We have never felt this pressure, but our guy has in game. I'm very impressed. We have like the best body ever, apparently, that doesn't get crushed under any pressure. It's very impressive. And just for reference, the pressure that you would be feeling would be equivalent to 527,087,206,600 watermelons. That's a lot of watermelons you're feeling underwater. You are living with the pressure of 527 billion watermelons on top of you, under there, and you act as though it's easy in the game. It's hilarious. But yeah, our guy's dead. A lot of things in this game don't make sense, knowing the gravity being 8,000 times stronger than Earth. A lot of things just mean that we have insanely strong legs to be able to jump at all. But our guy's dead. He died under 500 billion watermelons. I hope he died happy, at least. I don't know. That's the end of the video, really. He's dead. He's really dead. He's dead. But yeah, I know, right? Big shocker. A video game doesn't make sense. It's a video game. It should make perfect sense. Thank you for watching. That's really all. I had a lot of fun doing this video. If you really did stick around to the end, I appreciate it. Thank you. I know my upload schedule looks horrid, and that's because I'm in school, and so I don't have time for this often. I hope to be able to get a little more consistent, and I hope to do more of these videos. I really enjoyed them. I had a lot of fun doing the math for it. So thanks for watching. Thanks for sticking around at the end. I'll see you guys all later. You guys have a great rest of your day. Bye-bye.